All right, you should put a star on this one because action potentials are extremely important in the function of neurons, and I am very likely going to ask you about this in an essay on the test. Okay, so an action potential is a huge change in voltage that's going to cause the excitation of the cell. So this is when we get excited. In order for the excitation to occur, the local potential, that local depolarization, has to reach a threshold. The threshold is usually about -55. So we're going to have to get from resting membrane potential to about -55, which is our threshold. You can see that here. So we're going to start at time 0 and kind of walk ourselves through this action potential, looking at the change in voltage as we go. An action potential is non-decremental. It is all or none. You either hit that threshold and you have the full action potential, or you don't hit the threshold and nothing happens. And it is irreversible. As soon as you hit the threshold, the whole thing is going to go. You can't stop an action potential partway through. It doesn't work like that. Okay, so what I'm going to do is use these numbers to talk you through each of these steps, and I'm going to write out an explanation of what's happening at each of these spots. So we've got time 0, we're at resting membrane potential. We're going to have a local potential, which we saw in the last video, where there's going to be some depolarization. So what's happening to cause this local potential? So this is what's happening at number 1 is the local potential. So step number 1 is the local potential. We can kind of draw this on our graph here. All right, so we might start at -70, and the local potential is going to kind of bring us up a little bit here. And so we've got sodium ions that are entering the cell. So remember that sodium is positively charged. So when it enters the cell, it's going to become less negative, which means more positive. So you can see that this is going up. So you can see this local potential happening here. These sodium ions are coming into the cell, raising the voltage. So here at number 2, we have hit the threshold. So at number 2 here, we hit our threshold, and this means that the action potential is a go. So we're going to have an action potential. The next step here is called depolarization. This is just like what happened at the local potential, only now this dramatically increases faster. So you can see this, this curve is going to increase much faster. So at this point, we're going to see the sodium ions coming into the cell really quickly. The potassium channels are going to start to open, but we're not seeing any potassium leaving yet. So here's step 3, our massive increase. We'll probably get up to maybe positive 35 millivolts. And this is depolarization. So at this point, our sodium ion channel opens, and sodium ions are going to rush into the cell, making it very positive. The potassium ion channels start to open. They're not quite open yet. Step number 4 is up here. We're going to reach a peak. So at this point, my sodium channels have started to close. So you can see right here, we're kind of at that peak. Here's my sodium channel. It's closed. The sodium is not coming in anymore, so it's not making it more positive. Instead, my potassium channels are fully open, and they're going to start releasing potassium out of the So step number 4, this is kind of peak right here. So 4, we've reached the top. We've got the sodium ion channels are going to close, so there's no more sodium entering the cell. That means it's not going to continue to increase the positiveness. And the potassium ion channels open, so this is going to allow potassium to leave the cell. So when potassium leaves, it's going to take these positive ions and let them go outside of the cell, and that's going to make things more negative. So the lack of incoming positive sodiums and the loss of positive potassiums is going to start to turn this curve very quickly. Our next step here, number 5, is called repolarization. So during repolarization, the potassium is leaving the cell, and then eventually these potassium channels will start to close. So step 5, we're going to call this repolarization. This is where it's going to come down really quickly, all the way back down to resting. So the potassium channels are open, but starting to close here at the end. The potassium is leaving the cell quickly. Notice that the charge actually undershoots a little too far. So step 6 is hyperpolarization. So hyper means too much. It goes a little too far. By the time we reach here, the potassium channels have closed. So this is shut. No more potassium leaving. Notice that now outside of the cell we have potassium, and inside of the cell we have sodium. That's the opposite of what we started. I'm going to move this over. All right, so number 6 is down here. So 6 is hyperpolarization. This is an overshoot. So at this point, the potassium ion channels are closed, but the cell is going to be lower than resting potential. It gets a little too negative too quickly here. And we noticed that at the end of this, we had potassium on the outside of the cell and sodium on the inside of the cell, which is the opposite of where it needs to be to start another action potential. All right, the last step that's going to happen is we're going to resume resting membrane potential, and we're going to do that through the help of the sodium-potassium pump, just like we did originally at resting. So step 7 is we're going to come back up to this resting membrane potential. So I'm going to just resting membrane potential. And this is going to be thanks to the sodium-potassium pump, which is going to fix this issue. And it's going to put the sodium back on the outside and bring the potassium back on the inside to get the cell ready to start another action potential if it receives another. After each action potential, there is a refractory period. This is a period in which you can't start another action potential yet. An absolute action potential means that it doesn't, no matter how much you stimulate the cell, it is not going to start another action potential because it's already still doing an action potential. So all the way until we get back down to 70, you can't start another action potential no matter what you do. The relative refractory period means that it's just harder to start an action potential, and this is because we're below that 70 millivolts. And so it would need more stimulus to start an action potential here. Once we get back to resting membrane potential, then the relative refractory period would be over and the cell is ready to be excited again. So here we can see the action potential being conducted. So that second aspect of our cell is conduction. An action potential is usually going to start at this end of the cell and then need to move towards the axon terminal. So pink is showing you this is where the action potential is currently happening. This is where it was, this is where it's in that refractory period. And then back here is where we've already reset back to resting membrane potential. And so as this action potential moves, the refractory period will follow it, and then this part of the cell is ready for a new action potential. This is called continuous conduction. So you can see that this axon doesn't have any myelin. So this is slower because the action potential has to occur at every spot along this membrane until it reaches the end. When an axon is myelinated, this conduction goes faster. So the action potential happens here. But because this is myelinated, no sodium or potassium are going to be able to escape. They can't get out. That myelin is covering it. So the next place that the action potential can occur is right here. So instead of kind of having to go over every single millimeter, the action potential can actually just jump from here to there to there, and there to there. That's called saltatory conduction, and saltatory means jumping from one place to the other. And so this is just going to go faster because I can move from there to there faster than if I had to travel this whole road. So take a moment and describe that process of the action potential. See if you can describe all 7 of the steps from that picture as well as drawing the image.